Mason is going to be talking about the, yeah, the talk is there is a snake in the Birdhouse. Yeah, nice title. So it's all yours. Remember, for everyone, you can ask questions at the end, and you can type the questions in the Q&A option in Zoom. Go. Thank you. Good luck.
Awesome. Thank you very much. Hello, everyone. My name is Mason Egger, and today I will be presenting to you There's a Snake in the Birdhouse, Building a Python Culture at Verbo. So, quick introduction. I am currently a developer advocate at DigitalOcean. But before this, I was a site reliability engineer at Verbo, which used to be called HomeAway, which is kind of where the theme of the title of this talk comes from. Is HomeAway's old logo used to be a birdhouse, so that was where it came from, and then they changed the name and ruined the title of my talk. But there's nothing I can do about that. It still kind of works. When I first started at Verbo, there was no official support for Python in the Verbo ecosystem. I'm going to go into this a little bit more, but that's really kind of the starting point for it. And today I'm going to kind of tell you my experience of how I led the effort to build a Python culture at Verbo. This talk is a little bit different than some of my other talks before because this one's really, I would say, really anecdotal. I'm just going to basically tell you the story of what I faced when I got there, how I convinced my manager to allow me to start working on Python and start supporting Python in the ecosystem, and some of the lessons that I learned and some things that I found that worked when I was trying to convince people to use Python, some things that I found that don't necessarily work so well. So that's what this talk is going to be about. Who is this talk for? I always do one of these. This talk is for anyone who uses Python at their current job, but is currently you use Python at your current job, but you're unable to maybe use it in production or use it with more people, or maybe it's not quite supported. You want to build a stronger Python community at your current job, and you want to learn how to introduce or evangelize any technology, not just Python. So a lot of these tips and tricks that I'm going to give you are they work for Python, but in reality, this is kind of how to evangelize and teach things on a broader scale, not just necessarily Python. Hopefully, you'll be able to learn from my successes and my mistakes to bring Python or any technology that you wish to use into your current work environment. So, a little bit of background on the way that the systems work at Verbo. So engineers at Verbo deployed applications to an internal paths that my team built. So if you wanted to deploy an application, you basically would create a Docker file with your application inside of it, follow a list of instructions that we gave, such as tell us where your logs are, tell us what port your health check is going to be going across, whether or not you want live track it, what environment you are, just a whole list of things. And they would deploy it out to this paths. That was not Kubernetes based, by the way, because it was built before Kubernetes was even a thing. And that's basically what served all of the VRBO website, the Verbo website, and now has actually been migrated into the Expedia ecosystem. There were, at the time that I started, there were project templates that existed for the supported languages of the company. Verbo had initially started as a Ruby on Rails shop, but by the time I got there, almost all of the Ruby on Rails was pretty much gone. There was a little bit of lingering remnants, but none of it inside of inside of the ecosystem that I maintained. The supported languages that we had were Java and Node. And what this essentially meant is that you could go into basically an application generator. So say you had a new idea and you wanted to create something. We had a whole fancy system where you would go in, answer a few questions, and a project would automatically be generated for you. And then it would be ready to deploy into this ecosystem and would even be deployed automatically into the test ecosystem. So you could kind of see it working, very similar to say how a one-click works at DigitalOcean or sample applications work in other PaaS systems. So at that time, Java and then Node.js were the only two that were supported in this way. You could go what we called off-road with your applications, which meant in reality, the specs for the platform were very vague. As long as you had a health check and told us where to find your logs and all these things, the language didn't really matter. So you could build a Python app if you wanted to. And in fact, there was, I think, a handful, not a lot, but there were a handful of Python apps when I started, but there was no official support. So if your application started misbehaving, if something started breaking and you couldn't figure out why it was doing this, then you would be kind of on your own. Like we might be able to help you, but in reality, there was no official team that supported this. The Java and Node archetypes had their own team for this. So you could go off-road, but you really didn't want to. So that led me to kind of start the question, hey, let's start using Python. Verbo at that time was starting to get really into the machine learning and AI kind of things for some of the chatbots and things that we were building, but the workflows for that were not on the new system, and the ones that were very very suboptimal. So we decided to start figuring out, hey, what would it take for us to do that? And that leads to essentially a discovery meeting. So if you are trying to get a language set up at your company and you haven't really, you're just starting it, you're going to need to have a discovery meeting with key stakeholders. So you're going to want to meet with all of the people who you think might be useful or who might be interested in consuming this. So for me, I met with the data science teams, I met with the machine learning teams, and I met with some of the API teams to gauge the interest. Because as we know, Python and Flask is a great way of building great APIs, and data science and machine learning, well, that's just kind of where everything was. At least at Verbo, everything was being done in Python. So we led a discovery meeting, and this, after kind of pitching a couple of ideas, I come up with my first, what I call don't. And my first don't would be, don't build something that nobody wants. So some of the things that I was talking about was Flask or Django applications with databases, and those other kind of things. And nobody really wanted that. In reality, what they wanted was they wanted a way to either run basic data science or machine learning algorithms or notebooks and stuff, or they wanted to just create simple APIs, and they didn't really want like the full Django experience. So I quickly was like, okay, I evaluated what people wanted, and I decided, hey, let's not don't build something that somebody doesn't want. So we talked with these teams, figure out what the interest level is and what they want to actually build, like what would they actually use, and then it becomes valuable to them. Another great don't that is here is don't develop in isolation or avoid others' opinions. If I had just decided to build the Django app and what I was originally envisioning in my head and didn't get any buy-in, yes, it would have worked, but nobody would have wanted it. So you definitely want to get others' opinions and make sure that there are people who are excited to use this product. If it's not really, if it doesn't excite them, then the likelihood of them trying to use it isn't any good, and you'll waste a whole bunch of time trying to evangelize a language that nobody really wanted to use in the first place. So especially in these discovery meetings, it's great to just get as many opinions as you can, ask everybody in your company, because you need to be able to like sift through all of that and come up with a definitive plan. And the other hard thing is luckily when I was at Verbo, everybody was interested. But if you do a discovery meeting like this and nobody's interested, then that's sad. But it may not be the best use of your time to continue down this path if it's obvious to see that nobody's relatively interested in adopting either Python or whatever you're trying to evangelize at that point. So the result of this meeting was I decided to end up building a cookie cutter that creates a default Flask application for the platform that included built-in static analysis, unit test, project documentation was already set up, logging, metrics that reported back to Datadog, the base application itself. All of these things were built in. The CI/CD, all of the configuration files for the build and the deployment were already built in. So that is basically, that's what we decided that we were going to build off of. And what that leads to is build a complete product for them to use. Build something that everybody wants to use, where they don't really, if you open it up and it's the out of the box experience is great and everybody's ready to use it, that's awesome, and people will use it. If they have to go in, like say they want static analysis, but you didn't provide it and they have to go add it in, that's more work, that's more of a barrier for entry to them. Provide them with everything you think they would need, but make it easy to disable the things if they don't want them. So when I started building this archetype, when I started building this application that everybody could use at Verbo, I learned another good one is create a meaningful set of expectations and use cases. Don't fall into the trap of this will solve everything. That's not a really good way to present it. Python is great at many things, but there are other languages that outperform it in certain areas. So don't try to sell Python into situations that it may not perform the best at. So basically, create a base standard application for Python and data science specific applications with mini condos. That's what we decided to do. We had actually two different supported Python paths. There was the Python path of creating an API with Flask, and a lot of people in the company really liked that. But the data science people had much different needs. Instead of trying to make them use the other one, the standard one, we just split off and then added all of the other things that they needed, mini conda, some of the other, I'm not a data scientist, so I remember installing packages for them. That's about it. So we created use cases for people if the use case was big enough. Like if there was a big enough segment of the engineers that needed it, we would create a specialized one for them, hence the data science specific one. I had just mentioned this, but same thing with like when I said creating the static analysis unit test, provide an out-of-box experience with sensible defaults. So the project, whenever you run it, it should work. The static analysis should work with, you know, alerting on enough things. Like whenever I use Pilot, personally, I turn off like the refactor or the convention ones, because while they are useful, I don't need to fail a build over them. But if I have a missing import and that comes up as an error, then yes, I would like to fail the build over that. So that is what I consider a sensible default. I very clearly document how they can use this or turn this back on or make it more clear. But with sensible defaults, I just only go with what really, in my mind, mattered. And then at the same thing as I mentioned, provide everything. Unit test documentation was the one that people really liked because their projects were already set up with Sphinx, ready to go, their Flask apps, and it already used like the Sphinx Flask web plugin. So their project automatically generated documentation for them as long as they put the doc strings in. If you help people with their documentation and you give them a place to put it, they will actually do it. But I've learned, and if you've ever seen some of my older talks, if you don't, people don't write docs. I have a whole line of talks on documentation about that. So another really good one for you to do whenever I did when I was building the archetype is create good documentation around not only the process, like how to use it, but also why you would want to use it and why you chose to use things. So as you can imagine, if I'm creating an entire Python ecosystem, I have to think about what package manager. Am I going to use pip? Am I going to use pipenv? Am I going to use poetry? Like, what am I going to use? Am I going to use pip tools? There's so many different things. So you need to create a rationale of your decisions. So not only do you document the use of the archetype, how to use it, how someone, a getting started guide, document all of the known bugs and limitations, because there will be some, like there's going to be gaps and things. If you know it has a bug or an issue, document it. Let people know that it's going to be a problem. Rationalize why you chose technologies. I have, for everything I chose, between using PyTest for the unit test, using Pilot for the static analysis, we use pipenv for all dependency management, and because of we really like the lock file and stuff. We used Flask. I used a couple of other different libraries inside of the base application, but everything that I chose, I wrote very specifically, not only why did I chose it, but I also wrote all of their competitors. So under Flask, there was Django and Tornado, and I wrote not only that these were options, but why I chose not to use them. Because one, as you can tell, I'm not working there anymore, but that product is still in use. So if anybody ever needs to know why did I make this choice, they can go back and check my documentation, and it explains at the time that, you know, past Mason wrote it, what he was thinking about. And I also like to develop the write about the development journey. There's like a little mini blog in the documents for this project of, like, I got stuck on something for a week and learned a very valuable lesson about dependency resolution. And I wrote it all out, and I wrote out why I chose it and why I made why this section of code exists, what I was thinking when I was going through it. Because again, as you can see, I no longer work for Verbo anymore, but people still use it. So it's setting up the person who's going to inherit your code for success. Don't try to don't use, man, my grammar's bad. Don't use Python to try to solve every case. Whoa, wow, I can't even, trying to solve every Python use case with one tool. Okay, I remember what that is now. So what you'd need to do is, yes, Flask is great, but I had someone come up to me with Django, with a request for using Django, and they were going to use some database stuff, and they had a really good use case for it. And what I did was I made sure that whenever I created all of the sections, when I put it all together, I made it very easy to take out certain technologies and replace them. It would be easy to replace PyTest with, say, unit test if you wanted to, or replace Flask with Django. don't force people to use tools if they have a good use case for using a different one. Make it very easy, make the interfaces very abstract to where you could easily remove the pieces and put in a new piece in. We had someone use Django within the first couple of weeks of me releasing it, and they complimented on how easy it was to just take out Flask and put in Django, because the way the project was structured, the way that it integrated with the static analysis and the way the unit test, yeah, they had to change a little bit of the code, but it was not ingrained in so deep that it was impossible to change it. And then another really big one, because at the time that we were doing this, that I was building this at Verbo, we were discussing our open source strategy and our open source paths. Use as few internal or proprietary tools as possible. One, the closer you can stay to vanilla open source projects, the easier it's going to be for you to upgrade things. I have stories from my past that I could easily tell in another talk about dependency nightmares and the horrors of upgrading things that are 15 years past due. And that happened because we got locked into internal tooling. So don't do that. It makes it way easier to open source later if you don't have anything internal. One of the biggest boundaries you will face when you try to open source something, especially from a very large company, is, are there any company secrets? Is there any company magic that is in here? And if you've used nothing but internal stuff, and then the code itself doesn't really deal with those secrets, it becomes very easy to open source these things. So try to use as few internal or proprietary tools as possible. It will not always be possible. There were a couple things in my archetype that were very custom to our CI/CD pipeline, but it was very easy to take those out. By creating well-defined interfaces for us to be able to replace things, we were able to pull out the internal proprietary tools very easily. So this is weird. So at the time that I was doing this is just part of the story. We were working on basically the version 2 of the internal paths. For those of you that are paths nerds or do DevOps stuff, our initial version of the paths was built using Mesos and Marathon as our container orchestrator, and we were migrating into Nomad, which is a HashiCorp product. So Verbo's version 2 of the internal paths was being built at the same time that I was building the Python support. And what I was able to do with this, and I don't know to this day, like at the time, this was a good decision for me. This made sense for me. Some people may disagree. It was a toss up in the air. The Python archetype was only going to support version 2. As someone who was on the PAS team who was actively trying to migrate people onto the new, better, more advanced system, we decided to use the Python archetype as kind of a carrot and stick kind of thing, where we could lead people into the new PAS by only allowing them to do it on version 2. Now, if you knew anything about the PAS, it was actually relatively easy to port it over to version 1, but we didn't say that. So as we were building it, I was building concurrently with my team as they were building the PAS, and I was helping with that. I was also building this Python archetype. We were going to, as I said, we were going to use it to entice. This was really good because I could use this to take advantage of new features in the PAS and new things that we were trying to do. And people got excited about it because it was things that you couldn't normally do in the PAS system. However, this was also bad because I became very heavily dependent on the PAS development timeline. It took me 6 months to build this archetype. In reality, it should have only taken me 2 or 3, but because I constantly kept getting stuck behind the development of the PAS, whenever they would have an outage, or if at the time that they were building this PAS, they were still responsible for version 1. So if there were major outages on version 1, like all development time got lost. So I got stuck behind it. And also, as people were testing it and they found errors in the PAS, it was very difficult to distinguish an error between what was an error with my Python project and what was an error with the new platform. So the reason I bring this up is because this was both a success and a failure at the same time. It was a success because it did work to pull people over to the new version. People actively migrated into Python. They really liked it. But at the same time, it did leave a sour taste in a few people's mouths because the failures that were associated either with my code, which I'm not going to say my code was flawless. There were times that I failed, but at the same time, there were also times that the PAS failed. It kind of made it a push and pull. So if you're, I guess with this one, the lesson to be learned from this one is if you're trying to introduce Python in your ecosystem and say you're in a major DevOps change, like maybe you're going from, Magic VM to Kubernetes style deployments and they're building out that stuff, tying it to being released on Kubernetes could be a success for you, but it could also backfire on you. So just be wary that it will be difficult for end users to differentiate the difference between a failure of the paths or a failure of your actual application that you're building. So some testing that, some things for testing that I learned. Find yourself an empowered group of beta testers. So they will help you evangelize later. So I had a couple of customers, what we called customers. They were not really customers. They were internal people that were very excited about this application, about using Python. So they became my beta testers. Every time I released a new version, they were the ones that would update their stuff. And actually, some of them were kind of brave enough to run this in production when it, in my mind, I wouldn't have. They were that confident, and they loved it that much that they ran some of it in production before the internal paths was even ready, which led to some ancillary services that weren't terribly vital, but was really good because it helped us find bugs. You will need to find people to test your stuff, because after developing it for 6 months, I knew every happy path through it, and I started to become like I had blinders on regarding what was going on. These first people or first customers will actually attempt to use it in production, and it'll make your heart squeamish a little bit because you're like, oh, it's not ready, but they do it, and it's fun. Don't become upset or by the negative feedback or bug reports. It's really easy for us to sometimes take things personally when it comes to building these kind of things because we want it to succeed so badly because we're so invested in Python. The negative feedback or the bug reports is more often than not a criticism of Python, and not even really a criticism of you. It's just that what they are trying to use, how they're trying to use your product, is not fitting their needs. Take this feedback, adjust what you're doing to fit their needs, and they'll love it even more. So a couple of evangelism do's that I would definitely recommend doing if you want to evangelize not even the product. So this is kind of what I did at Verbo, is demonstrate the flexibility of Python. Let people know how easy it is to just write something, like bang out an application or something and show it. Show that it's good for APIs, it's good for data science, maybe it's good for log processing and stuff like that. Show all of the different things that I can do, and people will come to love what the language does, and they will want to adopt it. Rewrite existing applications that are considered troublesome or complex in Python. If you have old languages or old applications that are always going down, or you're constantly having to fix them because they're just unstable or they're just overly complex, try rewriting them in Python. I have found many times that whenever I rewrite complex C or Ruby applications in Python, they become less complex just because of the nature of the language. So by doing this, what you can do, say with your manager, is instead of patching this for the 10 billionth time, can I try just rewriting it really quick? Can I just get like a sprint to see if I can replace this application, or at least get a proof of concept of this application in Python running, hopefully at the same performance level. And it's easier to understand, it's easier to maintain, because maintainability is one of the big things, especially when you're in like a DevOps or an SRE thing. Write new applications or features in Python. If you're adding a new microservice or a new API or something, pitch the idea that, hey, let's just try it in Python. We have this, we've done everything we've done so far in Golang or Ruby or something. Let's try it in Python and just see how much easier it is. If we don't like it, we can always go back and rewrite it. But let's just give it a shot. Let me try it. You'd be surprised how often people are willing to let people just go and try something on their muse. Managers are meant to they're meant to trust us. They have to trust that we know what we're doing and we know what's best for the company. And I'm not saying Python is better or worse than any specific language, but we as Pythonistas know how easy it is to maintain Python. And in reality, the ease of maintainability of a programming language, of source code, is more important than almost anything else. Yes, performance is great and all that. We can get very close to that with Python, but if I can't maintain it and it becomes unruly, then it becomes a black box, and then it's its own set of problems. Be the temporary solution. This is kind of what I consider kind of a sneaky way of showing the powers of Python, but it does work. I may have done it once or twice. if there's an outage or something's going wrong, or you need to write a tool or a piece of code or an app really, really fast, just say, okay, I know I can write this in Python really quickly. Let's go ahead and just write it really, really fast. And you'd be surprised how often those remain in production. As my ex-boss used to joke with us, and I used to laugh at it, but then I realized it wasn't really a joke, and it kind of makes me sad. There is no discernible difference between a proof of concept and production software. I have a whole story about that if you want, I can tell you about it later, where one of my test pieces of code made it into production. I'm still upset about that. Some evangelism don'ts when you're trying to evangelize Python or anything. Don't say that language sucks, you should use Python, or you should use X. As we as Pythonistas know, people are very protective of their language. They're very opinionated when they come to the language. People don't write in a certain language because they don't love it. Like, we love Python, that's why we choose to write Python. So if you come off confrontational from the get-go, not going to be a good, you're not going to win anybody's affection. And all you're going to do is you're going to put not only a negative connotation around Python, you're going to put a negative connotation around the Python community, which is honestly I would say some of the bigger damage, or the worst damage you can do, because the Python community is amazing, hence all of us being here. So just don't do it. Don't come off adversarial with this stuff. It really doesn't work out. Don't try to use Python to solve problems that Python doesn't handle well. If you need a super high performant multi-threaded thing that behaves at the level of C and is really, really, really fast and really, really high performant, amazing amount of cores, maybe Python's not the best thing for that. It might be, but maybe it's not. Maybe Golang and C might work a little bit better there. Whenever people see things fail, they tend to blame it maybe on the language itself. So, and it's really, if you put Python in a situation that it's not equipped to run or do as better than other languages, and it fails, people blame the language, when in reality, it's not the language's fault. It's actually your fault for picking the wrong tool. I don't try to screw in screws in my wall with a level. It just doesn't work. Like, you can't do it. So don't do that. It's a really bad way to give people a negative impression of a language right off the bat, and those impressions stick. Don't be overbearing. If someone isn't interested in using Python right now, that's okay. Don't be like a pusher and constantly trying to push it. Continue to do what you're doing. Continue to build cool tools and stuff. Continue to show off some of the neat little things of Python, and eventually you may change their mind. But if you don't, that's fine too. It's totally fine for not everybody to write Python. The world couldn't exist if we didn't have all these programming languages. This is what makes computer programming and software engineering such a fascinating field to study. So don't be overbearing. Bring it up every now and then, but if you become annoying, then it's not going to go over well. So that's pretty much my story. The results that I can say that I saw from this are, within the first month, 80 applications within inside of the ecosystem were using the new archetype in production. So there was a demand for Python. Whether or not people were openly saying it, and there was a small group that was, people did want it. And then by other people showing other people in the company, it kind of began to grow. Other people also then started using my development journey documentation to start building support for Golang. So not only did I influence people using Python, I started influencing other languages being supported within the company through this. So proper evangelism of a good project and proper documentation of all this can actually help support the evangelism of other projects. You can support Golang and you can support other things. It's all a harmonious system and we all live very well together. So that's my story. Like I said, this is a very anecdotal story of my experience inside of the industry. Thank you for tuning in today. Feel free to tweet me if you have any questions. I'm at Mason Egger on Twitter. You can also message me in the Discord. I will be happy there to discuss anything regarding this talk or just anything in general. I like talking to people. And if you like listening to me present and stuff, I do a live stream at 1 o'clock on Tuesdays. Feel free to come and see me. And if that is everything, then I will turn it back over to our moderator.
Thank you very much.